So now we see the next part of the preparation of salts, and that is the preparation of lead nitrate. So we saw the last video containing the 4 different methods. Now this is the last method, that is preparation of lead chloride and calcium carbonate. So we are having over here the preparation of lead chloride and another thing is calcium carbonate. So these are the 2 salts which are going to have a similar method. So both of them are working in the same method. So that's why we are taking them together. So the reaction goes this way. It is basically, we see that both these salts are insoluble in nature. So one thing is that up till now we saw only soluble ones. Soluble ones were taken out with the help of crystallization or evaporation, but now it is insoluble, so we are going to get it as a precipitate. So what we see is a reaction wherein you will be using a lead salt which is soluble. So we are taking PbNO3 twice and we are going to react it with NaCl. So once you react with NaCl, what you will be getting is PbCl2, which is a precipitate, plus NaNO3. So this is what is the reaction like, and this is what we actually require. Same thing happens for calcium carbonate also. So if we take CaCl2 and we take over here Na2CO3, you get over here the CaCO3 and precipitate plus NaCl. So that is how you are going to have the thing done. Yeah, this is 2 over here. So this is what we want. For this, the method is exactly the same what we use for any kind of a double decomposition reaction. So you are taking a container. Now in this beaker, you are, instead of taking the acid, up till now we took acid, now we are going to take over here will be a solution of NaCl, or in the next case it is Na2CO3. So you are going to take the water and you are going, or instead better way is that we are going to send this 2, we are going to add into water directly. So we are going to take water over here. So this is water, and this water we are going to add to this the 2 things over here, that is PbNO3 twice and NaCl. So these 2 things we are going to add directly into it and stir it. Okay, so we are going to take PbNO3 twice crystal and dissolve them in water, add to it an aqueous solution of NaCl. So it is both ways. You can take a solution of this one and a solution of this one and mix them together, or you can add directly in water, your choice, doesn't make much difference. So basically you are going to take a mixture of these 2 salts in water. Now as soon as you do that thing, so a white precipitate of lead chloride slowly appears on stirring. So when you keep on stirring, heat is not required. As you keep on stirring, you are going to get a small quantity of white precipitate of PbCl2 will be seen at the bottom. The precipitate is filtered and washed repeatedly with cold water. So, and then transfer of precipitate is carefully transferred into a evaporating dish. So very simple. What you get this thing, you are going to take that particular solution and filter it out. On the filter paper, what is being used, you are going to get the precipitate. What was there is available on the filter paper. So that filter paper का जो material है, you are going to slowly transfer it into evaporating dish, and then of course crystallization. So crystallization, the precipitate of lead chloride formed is dissolved in the minimum amount of water and heated, and PbCl2 dissolves in hot water but is insoluble in cold water. So pure crystals of PbCl2 hence separate on cooling. NaNO3 is soluble, is hot in cold water and remains in the solution. So NaNO3 is going to remain over here itself. This part over here, this one and this one, they will remain inside the water, and what is going to be given out will be in the form of only PbCl2. So the crystals are filtered out carefully and dried when needle-shaped crystals of lead chloride are obtained. So this is when for lead chloride. Similar thing also for calcium chloride. Aqueous solution of calcium chloride and potassium carbonate are mixed together and stirred. A white precipitate of insoluble calcium carbonate is obtained, which separate out from the aqueous solution. The precipitate is filtered out carefully and washed with cold water. So sodium chloride is soluble in water and remains in the solution, and drying of the precipitate is obtained amorphous powder of calcium carbonate. So you can see in this way you are able to get the insoluble salts using the method of double decomposition. So these were the different methods or different ways the preparation of salts takes place. So we saw that the preparation were taking place as per, there are 5 different methods. So the first method was of the neutralization. The next one was neutralization with titration. The third one being direct combination. The fourth one being double decomposition. Both one being the third one was active metal reacting with the acid. The fourth one being direct combination, and the fifth one being the double decomposition, but using the insoluble or getting the insoluble salts. So when you want the insoluble salts, you are using the double decomposition over here, where we get everything as a precipitate. So this was about the preparation of the salts. Now we come to the last part of the chapter, that is general properties of salts. This part is very, very important again, because this tells you a lot of about the properties, or in which the way the salts are going to behave. So that's why it is quite important. The first thing, the properties of salts. Salts are non-volatile electrovalent compounds. Yes, each and every salt which is going to be formed will be formed by an electrovalent compound, because salts are a formation of the metals plus non-metals. So there will be a cation and an anion combining together to give you a salt. So that is non-volatile. Yes, they are non-volatile. Secondly, why they are non-volatile? Because they are electrovalent bonds. All electrovalent bonds are non-volatile, because electrovalent bonds are very stable. So that's why they are not going to react so easily. So non-volatile electrovalent bonds. Again, property of electrovalent bond, they have high melting and boiling point. So yes, have a high melting point and are soluble or insoluble in water. They exhibit 2 things. One is deliquescence. Right? The first one is deliquescence, and second one is efflorescence. Okay, so they exhibit these 2 particular characteristics, and they also have one more important thing, and that is water of crystallization. So it is not necessary that each and every salt will have a water of crystallization. So if a salt is crystalline in nature, it doesn't mean that it has to have a water of crystallization. But yes, many of the salts which are crystalline in nature are crystalline due to the presence of the water of crystallization in it. Okay, so it is the water of crystallization is the amount of water which enter into loose chemical combination with one molecule of the substance or crystalline from its aqueous solution. So when you see that when the amount of water, there is a fixed amount of water which is going to be associated with one molecule of the salt. Like we have over here, the example is CuSO4.5H2O, then you have got over here CaSO4.7H2O. So all these are the different examples. There is gypsum, there is blue vitriol, then the Epsom salt, Glauber salt, washing soda. All these are the examples of salts who have got the water of crystallization in them. So salts which contain definite number of water molecules as the water of crystallization are called hydrated salts. For example, that is CaSO4.2H2O, that is gypsum. This is CaSO4.2H2O. This is gypsum. Okay. Then this is CaSO4.5H2O, which is blue vitriol, which is nothing but copper sulfate. Okay. Then we have got CaCl2.6H2O, then MgSO4.7H2O, which is Epsom salt, Na2SO4.10H2O, global salt, and Na2CO3.10H2O, washing soda. The salts not containing water of crystallization are called anhydrous salts, that is anhydrous CuSO4. So if you have got CuSO4 but no 5H2O connected to it, then you call that particular salt to be as a anhydrous salt. So whenever a salt is there which is in the form of crystalline form, which has normally due having some water of crystallization, and that water of crystallization is removed, then we call the remaining part of the salt as an anhydrous salt. So water of crystallization, we understood that it is certain particular number of molecules of water associated with one molecule of the salt, which makes the salt into a crystalline form. Okay, that was nothing but water of crystallization. We now move on to the thing which is deliquescence. So water soluble salts which on exposure to atmosphere absorb moisture from atmosphere, dissolve in same and change into a solution. So see, when we talk about the salts, we see that salts are hygroscopic. What do you mean by hygroscopic? They are having an affinity towards water. Means they have a tendency to absorb water or absorb moisture. So when they have got a strong affinity towards water and they absorb the moisture from the water, from the air, then there are certain amount of salts, certain types of salts which are called deliquescence. Now what happens in deliquescent salts is, you take the salt is going to absorb the moisture from the atmosphere, and then that moisture, in that particular moisture itself, this salt is going to get dissolved in it and form a saturated solution. So when a particular salt is going to absorb the moisture from the atmosphere, get dissolved in it and form a saturated solution, such a kind of a salt is called as deliquescent salt. Okay, or the process is called as deliquescence. So what is deliquescence? Water soluble salts which on exposure to atmosphere, so on exposure to atmosphere, absorb moisture from atmosphere, dissolve in the same and change into a solution. So that is deliquescence. The phenomena is called deliquescence and the salt deliquescent salts. Iron chloride FeCl3, anhydrous calcium chloride, magnesium chloride, zinc chloride, iron nitrate, copper nitrate, substances which absorb moisture from atmosphere without dissolving in it are hygroscopic. They are used as drying agents, that is calcium oxide. So yes, if it does not form into its solution and it is just going to absorb the moisture without any change in its physical state, then these are called as hygroscopic. So salts which are having the affinity towards water is hygroscopic, but hygroscopic में भी एक ऐसा टाइप कि वो खुद dissolve होके solution बन जाए, that is deliquescence. Okay, so that's why we have the hygroscopic. Now these hygroscopic substances which do not change their state or do not form into solutions are also called as drying agent, are used as drying agents. FeCl3, a deliquescent salt, is stored in a closed container. It turns yellow on dissolving in water. So this is the thing, that salt, that is FeCl3 salt, is going to be deliquescent in nature. The next is efflorescence. So this is efflorescence. ये उसका उल्टा है, यानी क्या, एटमॉस्फेयर के कांटेक्ट में आएगा, इसका वाटर ऑफ क्रिस्टलाइजेशन भाग जाएगा. ओके, सो crystalline hydrated salts, okay, those salts which are crystalline in nature, they are hydrated in nature, hydrated kind of salts, that means they have got a water of crystallization in them, which on exposure to atmosphere lose their water of crystallization partly or completely and change into a powder. So when a particular salt, if I keep it in open, if it is crystalline in nature and after some time it loses its crystalline form and forms into an anhydrous form, this is nothing but efflorescence. So in efflorescence what happens? The water of crystallization present in the salt escapes out into the atmosphere. It is going to be released. The water of crystallization is going to run away. It is going to just get dehydrated. So the salt, which is a hydrated salt, automatically on exposure to the atmosphere becomes dehydrated, and then it becomes anhydrous. That particular kind of salt which loses its water of crystallization on coming in contact with the atmosphere is called as efflorescent salt, and the process is called as efflorescence. So crystalline hydrated salts which on exposure to atmosphere lose their water of crystallization partly or completely and change into powder, is the phenomena is called as efflorescence, and the salts are efflorescent. Examples are CuSO4.5H2O, MgSO4.7H2O, Na2SO4.10H2O, and Na2CO3.10H2O. So you can see all the sulfates and carbonates are here, whereas chlorides and nitrates were over here. So these are normally the chlorides and the nitrates. You can just see these are certain observations which you need to make so that you can remember things more easily. You can see the examples. When you see the examples, you found that most of this over here where the examples were given were chlorides and nitrates, whereas the example which are given over here are sulfates and carbonates. Okay, so now you can easily make out कि कोई सल्फेट दिया ना वो efflorescent होगा, right? Chloride दिया then it should be deliquescent in nature. So this is how you can slightly identify those things or help you in learning these things. Now we come to another thing which is hydrolysis of salts. So the next point over here is given as hydrolysis. Or I'll just erase this part. It's called hydrolysis. Reaction in which salts react with water to form base and an acid, that is a solution which is acidic, alkaline or neutral in nature. So we can say that whenever you are going to use a reaction in which you are going to get a base and an acid. So okay, when a salt and water, it is something like when salt plus water gives you base plus acid, that is hydrolysis. यानी something, yes, to a certain extent, yes, ulta of neutralization. Okay, the reverse reaction of neutralization is hydrolysis. But here there are certain conditions required for the neutralization, for this hydrolysis to take place. It is not just going to be general. So we see the reaction in which salt reacts with water to form alkali and an acid. Okay, to form a base, that is an alkali, it's a soluble base, and an alkali, that is a solution in which acid and alkali or neutral is in nature. So if the reaction gives you a particular kind of a solution which is acidic or alkaline in nature, then it is going to be hydrolysis. So we know that neutralization reaction we have weak alkaline and strong acid. So if the reaction is such that there is a weak alkali and a strong acid like NH4CaOH and HCl, we get NH4Cl and H2O. Strong alkali and weak acid, so NaOH and H2SCO3 will be giving Na2CO3 and H2O. Strong alkali and strong acid, NaOH plus HCl giving me NaCl plus H2O. So you see, these are the three conditions of neutralization. Neutralization कब कब हो सकता है, कैसे टाइप का हो सकता है? One is weak. We have first one as weak alkali plus strong base. Sorry, strong acid. Or we have strong alkali and weak base, weak acid. Or we have strong alkali plus strong acid. Right? These are the three ways possible. Normally weak acid and weak bases will not form, but these are three. So in case it is so that NH4Cl, so what will happen is when the reverse of this thing takes place, so we have the first reaction as, so we are taking the weak one. So when the reverse of this takes place, यानी क्या? We have NH4Cl plus H2O, and when it gives me a weak alkali, that is NH4OH plus HCl, then the solution will be slightly acidic in nature. So the solution will be acidic in nature. Because if you take a litmus paper, you will find that the purple will turn red. So this kind of reaction, so when NH4Cl plus H2O is giving me NH4OH plus HCl, so it is a weak alkali and a strong acid is available over here, then it will be acidic in nature. If it is this way, that NaHCO3 is combining with H2O to give you the reacting thing as NaOH, that is strong alkali, and a weak base NaH2CO3, then it will be basic in nature. So alkaline, that means a purple color will turn blue. So this will be the condition, it will be turning blue. The same thing can also happen for NaCO3, will give you the same results. So again the purple will turn blue. Third one is if there is a strong, that is NaCl reacting with H2O, and that gives me over here NaOH plus HCl. In this case it will be neutral. Okay? When both are strong, both are strong, then the solution what I will be getting will be neutral, so there will be no change in the litmus paper. And finally we have got one more, that is MgCl2 plus H2O is going to give me MgOH twice plus 2HCl. In this case again, this is weak and this is strong. That's why this is strong, that's why it will be acidic in nature. So what is hydrolysis? Hydrolysis is a process in which the salt is going to react with water to give you a base plus acid, and accordingly the solution of this base plus acid could be acidic in nature. If it is weak alkali and strong base, it would be alkaline in nature. If it is a weak base and a strong acid, it will be a strong base and a weak acid. It could be neutral if both of them are strong, and it could be again acidic if this is weak and this is strong. So this way you can see that how hydrolysis is going to take place, and what is hydrolysis. So it is just that when a salt reacts with water and the solution what we get is either acidic or basic or neutral, then it is that particular method or that particular process of the mixing of this thing is called as hydrolysis. So this was about the chapter. You can see it's the end of the chapter now. So this was a complete chapter acid, bases and salts. A very very important chapter, and please go through it properly, right?